In this video, let us study how to solve equations using matrices. Now, let us take simultaneous equations. Ax plus by is equal to m and cx plus dy is equal to n. These are simultaneous equations. It can be solved using elimination method or substitution method. But here we are going to study how to solve these equations using matrices. For this purpose, we have to convert these equations into matrix equation form. And for making the matrix equation form, we have to create matrices out of these equations. For creating matrices, we have to consider the coefficients of these variables. Now, the coefficient of x here is a and that y is b. Then here in the second row that will be c and d. Now, considering a, b, c, d, that is the coefficient of all the variables in the equations, we are going to create a matrix of a, b, c, d. We have to put it in that order itself. So in order to keep it in order, we have to first see whether the equation is in order. Both equations must be in the same order. That is, first is the x variable component, then comes the second y variable component. And here also, first is x variable component and then y variable component. So both of these equations are in order. And in the right hand side elements are also there. So both of them are in the same order. Hence, it is easy for us to form a matrix out of it. Matrix of A, B, C, D. A, B, C, D. That is how we form this matrix. And then our next matrix is matrix of the variables. Matrix of X, Y. Then coming to the right hand side, we have to form a matrix of these elements also. So that is equal to matrix of Mn. Now this is in matrix equation form, that is Ax is equal to B. A matrix is the matrix formed with the coefficients and X matrix is the matrix formed with the variables and B matrix is the matrix formed with the elements in the right hand side. Ax is equal to B is the matrix equation form. So, when we get a simultaneous equations, we have to convert that equation into matrix equation form for solving it using matrices. And now, let us take an example. 2x minus 3y is equal to 3, 4x minus y is equal to 11. We have got simultaneous equations. First of all, in order to solve these equations using matrices, we have to convert it into matrix equation form. And for expressing in matrix equation form, we have to take the coefficients from these equations. Before that, we have to analyze whether these equations are in the same order. Here, the first component is x component and then y component in both the equations, and in the right hand side elements are also similar. So these equations are in order. Hence it is easy for us to convert it into matrices. Let us create a matrix using the coefficients in both the equations. Matrix of 2 minus 3 4 minus 1. We have to create it in that order itself. The first column should be comprising of the first coefficients and then the second column the coefficients of the same variable, that is y. So in that order we are creating this matrix. Then this matrix into the variable matrix, that is matrix of x, y. And that is equal to, you have to create the next matrix out of the elements in the right hand side, that is matrix of 3, 11. Now we got these equations in the matrix equation form. Ax is equal to B. A matrix is the matrix formed using the coefficients in the equations in the left hand side, and X matrix is the matrix formed using the variables in the equations, and B matrix is the matrix formed using the elements in the right hand side. So AX is equal to B. So what we have to find is X matrix. X matrix comprises of X and Y. So in order to get the values of X and Y, we have to find X matrix values. So keeping the X matrix on the left hand side, we have to take A to the right hand side. It becomes X is equal to A inverse B. We know that when taking a value from the left hand side to the right hand side, or from the right hand side to the left hand side, plus sign becomes minus sign becomes plus sign, division becomes multiplication, multiplication becomes division. And what happens when we are taking a matrix from one side to the other? It becomes inverse of that matrix. When A is taken from left hand side to right hand side, that becomes A inverse. So X is equal to A inverse B. So our next step is finding A inverse into B. A inverse is equal to 1 divided by determinant of A into H A, or that is same as H A divided by determinant of A. So we have to find determinant of A and H A to get A inverse. What is determinant of A? There is a determinant of A matrix. So determinant of A is equal to determinant of 2 minus 3, 4 minus 1. That is equal to 2 into minus 1 minus 4 into minus 3. That is equal to 10. Now we have to find HA. For finding HA, we have to get all the cofactors. Cofactors of all the elements in the matrix. So the first element alpha 1, 1 is equal to minus 1 raised to 1 plus 1 into minus 1, that is equal to minus 1, and then alpha 1 2 is equal to minus 1 raised to 1 plus 2 into 4, that is equal to minus 4. Alpha 2 1 is equal to minus 1 raised to 2 plus 1 into minus 3, that is equal to 3. Alpha 2 2 is equal to minus 1 raised to 2 plus 2 into 2, that is equal to 2. We have already discussed how to find the cofactors of elements in a matrix in the other video. And we know that HA is the transpose of the cofactor matrix. So HA will be equal to matrix of minus 1, 3, minus 4, 2. This is the transpose of cofactor matrix. So first we have to find the cofactor matrix, then take the transpose of that to get the HA. Then A inverse is equal to, according to the formula, 1 divided by 10 into HA. Once we get A inverse, we have to apply it in this formula. X is equal to A inverse B. So 1 by 10 into HA, that is A inverse, that into B. So that is equal to 1 by 10 into minus 1 into 3 plus 3 into 11, that is the first row. Then minus 4 into 3 plus 2 into 11. Here we are multiplying the HA matrix with the B matrix and keeping the 1 by 10 as such for dividing as the last step. Hence that is equal to 1 by 10 into matrix of 30, 10. Thus it becomes easier for us to divide 10. So that is equal to matrix of 3, 1. Now we know that X matrix is equal to matrix of X, Y. That is equal to matrix of 3, 1. Now X is in the same position of 3 and Y is in the same position of 1. Therefore, X is equal to 3 and Y is equal to 1. This is the solution for the simultaneous equations. We got the value of X variable as 3 and the value of Y variable as 1. The same solution will be obtained even if we apply any other methods. So this is how we solve simultaneous equations using matrices. And in the same manner, we can also solve simultaneous equations with three variables. In the same manner, we can do that also. Thank you for watching this video. For more videos, subscribe the channel.